If you're just memorizing the textbook for the Cambridge Physics 0625 exam, you're stepping into a massive trap. This isn't just a test, it's a boss fight. Today, we're breaking down the exact attack patterns examiners use in the forces section, covering mass, weight, density, pressure, and resultant force. Let's jump right in and look at the first trap that catches thousands of students every single year.
Take a look at this standard-looking 4-mark question. Calculate the density of the object and describe one practical improvement. This right here, it's a classic double-barreled trap. Most students see the word calculate, grab their calculator, find the density, write it down, and completely ignore the second half of the sentence. They entirely miss the second command word, describe. And missing that second command literally guarantees you're throwing away grade boundaries. You do all the hard math and still lose half the marks just because you didn't read the full attack pattern.
And that brings us to the ultimate stakes, 0. That's exactly how many marks examiners give when you round your numbers too early in a multi-step calculation, or, just forget to write down the final units. Imagine the absolute confidence shock of doing all the complex resultant force geometry perfectly, but getting a 0 because you left off the newtons. Or maybe you rounded a 3.33 intermediate step down to 3, throwing off your entire final answer. The mark scheme has absolutely no mercy for this.
This is exactly why your ordinary revision fails. Just knowing the equations for mass, weight, pressure, and resultant force simply isn't enough to survive. You can memorize density equals mass over volume or pressure equals force over area until you're blue in the face, but the examiner's attack patterns are designed to test your application, your reliability, and your accuracy. If you can't identify experimental variables, or if your conclusions aren't directly supported by the data they give you in the exam, your memorized formulas are basically useless shields.
So how do we build up a defense? Well, here are some quick wins to instantly secure your method marks. First up, always check your graph scales first. Examiners love to use non-standard scales just to mess up your gradient calculations. Seriously, watch out for that. Second, write the raw equation down before substituting any numbers. That way, if you mess up the math, you still get the mark for knowing the formula. And third, lock in your SI units immediately. Convert those grams to kilograms and centimeters to meters before you do anything else. These simple habits act as an instant shield to protect your baseline marks.
Now, let's look at a foundational concept before the stakes get even higher: resultant force. It's the overall single force acting on an object that determines its acceleration or deceleration. It's the vector sum of all forces. You need to know this definition cold, but remember, knowing the definition is just level 1. The examiner won't just ask you to define it, they're going to make you apply it to a complex scenario with opposing forces, friction, and air resistance.
In a moment, I'm going to show you the exact examiner clue that changes your answer completely. But first, you need the framework that makes that clue completely obvious, because if you don't know how to structure your thoughts, even the most glaring clues on the exam paper will just look like extra, confusing text. Leaving this explainer now means missing out on the ultimate mark scheme secret, so you absolutely need this next methodology if you want to survive.
Section 1. The winning answer framework. This is your ultimate defense mechanism.
To guarantee every single point against the Cambridge marking system, you've got to follow these 4 unbreakable steps for a top band response. Step 1. State the core physics concept. Step 2. Pull evidence or data directly from the source material, the graph or the table provided. Step 3. Provide the scientific reasoning linking that data back to the concept, like proving exactly how acceleration changes when a new resultant force is introduced. And Step 4. Use specific examiner wording. That's the exact terminology the mark scheme demands. If you follow this chain, your answers become completely bulletproof.
Moving to Section 2, level up. We're looking at flawed versus perfect.
Let's apply this exact 4-step framework to a really common mass and weight question, so you can see the difference between a C and an A star. Notice the contrast here. Look at the flawed answer on the left. Weight changes because gravity is different on the moon. Okay, it's vague, it's true, but it earns maybe 1 mark. Now look at the improved top band answer on the right. Weight decreases, W equals mg, and the gravitational field strength G is lower. Do you see the difference? The improved answer states the exact direction of change. It decreases. It provides the concept and reasoning using the W equals mg equation, and crucially it uses the precise examiner wording, gravitational field strength, not just gravity. That, right there, is how you secure all the marks.
All right, Section 3, boss fight. It's time for an interactive challenge.
The stakes are going up now. I'm going to show you a set of data, and I want you to put on your strictest, most ruthless Cambridge examiner hat to find the hidden trap. Look really closely at this data table from a practical investigation. We've got 3 readings. Reading 1, Mass 50, Volume 10, Density 5.0. Reading 2, Mass 100, Volume 20, Density 5.0. Reading 3, Mass 150, Volume 22, Density 6.8. Scan this data right now. What is happening with the mass and volume? What's the resultant density? There is a glaring issue here that the examiner expects you to catch instantly.
So, the crucial point is this. Can you spot the anomaly? And more importantly, how would you improve the reliability of this experiment? I actually want you to pause and mentally write down your answer right now. Seriously, formulate your exact wording before the examiner strikes. How do you handle flawed data? And what specific action makes it reliable?
Section 4, Examiner Verdict. Out comes the red pen.
Okay, time's up. Let's see if your mental answers survive the actual mark scheme reality check or if you just fell into the trap of giving a vague, generic response. First off, you had to explicitly identify reading 3 as anomalous. Why? Because a density of 6.8 wildly deviates from that consistent 5.0. Second, if you're asked for an average, you absolutely must state that you do not include reading 3 in the mean calculation. Including it costs you the mark right then and there. Finally, to improve reliability, vague answers like do it better or improve the experiment score absolutely 0. You have to specifically state, repeat the readings and calculate a new mean. That is the exact wording required.
Check out this direct quote from actual examiner feedback. Conclusions were often not supported by data, and weak practical improvements cost crucial marks. This completely reinforces the stakes we've been talking about. If you ignore graph gradients, if your data analysis is sloppy, or if you just guess at improvements without tying them to the specific experimental apparatus and variables they gave you on the source page, you are going to bleed marks.
Section 5, the final gap. Are you ready for the next level? Here's the thing. Even if you know the physics equations and the data rules inside and out, it isn't enough if you misread the actual rules of engagement. The real unresolved trap lies in the command words. The difference between calculate and explain is massive. Describe requires a totally different answer structure than evaluate, and treating a data analysis question like a practical investigation question that's going to result in 0 marks. The wording the examiner uses at the very start of the sentence dictates the entire mark band. If you can't decipher these command words, you're practically fighting blind.
Because the next boss fight is purely about deciphering those command words, this next explainer is your absolute survival gear. You now know the physics concepts and the data frameworks, but to unlock the top mark bands, you have to decode the examiner's language. Watching command words that decide the mark band is a mandatory requirement to ensure your knowledge actually translates into marks on the page.
Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. But before you click over to the next explainer, ask yourself this. Do you truly understand what the word evaluate demands in a 6-mark question? If you hesitate for even a single second, well, you know exactly what you need to watch next. See you there.